Friday Math Happy Hour. This presentation will be a little bit long because for the math 0324, for the NCBN 0324 and Math 1324, this is like a mini master. It's like a 5-week course. And most of the 1314s, they go for 10 weeks. But the 1324, they only go for 5 weeks. So I'm covering like 2 chapters in one, or like 3 chapters. I mean, really 2 chapters. But today we're going to cover factoring, exponential equations, and logarithmic equations, which I believe these are chapter 4. And simple interest, compound interest, and annuities are chapter 5. So I'm covering 2 chapters and also plus factoring because factoring is crucial. Okay, so these are the topics that I'm going to cover. Okay, so it's factoring, writing logarithmic equations into exponential equations, writing exponential equations into logarithmic equations, graphing exponential and logarithmic functions, expanding and condensing logarithms by using properties, solving exponential equations by using the same base rule, solving exponential equations with different bases, solving logarithmic equations by using logarithm properties. And then chapter 5 is 5.1 is simple interest, 5.2 is compound interest, 5.3 is future value annuities, and finally 5.4 is present value annuities. So let's begin with factoring. Okay, the purpose of factoring is to actually find the zeros. The zeros, the x-intercepts, solutions, or roots, it all means the same thing. Okay, for example, this is a quadratic equation, right? So these are what we're looking for. These are the x-intercepts or the solutions, zeros, or roots. It all means the same thing. And this is the actual equation here. Okay, for example, you see this is x equals to -4 and x equals to 2. So this is, I'm going to show you how to find the factors, how to factor to find the solutions. Okay, now these are all real life examples of parabolas. You see, for example, everything that has an arc is like a parabola. You see these have like an arc here, right? So all these are examples. So let me move on. Okay, now the way I show factoring, guys, is kind of different than the book. It's a little bit modified. Okay, but my intentions are always to accommodate also the non-traditional students. And at times when students come back to school at like a later age in their lives, at times they come back and they're real confused with some of the material because they haven't been to school in a while. So I like to use the factoring steps which I came up with, and also the factor sheet. These are very crucial for factoring, and I'm going to cover all these steps here in order to factor. And we're going to be using the factor sheet, which is this on the right. Okay, now the first step, right, the steps to factor is number 1 is find the GCF, which is called the greatest common factor, or what is the highest factor to factor out. Then once you do step 1, right, number 1, then you go to number 2, determine the number of terms. And make sure that the terms are in order. If not, rewrite in order from highest degree to smallest degree before continuing. So after you do step 2, then you go to 2a, which is if you have 2 terms, it's either going to be perfect squares or perfect cubes. If you have 3 terms, it's going to be either the x squared plus bx plus c form or the ax squared plus bx plus c. And if it's 4 terms, it's going to be by grouping. So I'm going to show you how to factor in any different way, okay, by following these steps here. Okay, now you also have to know some of the vocabulary. For example, quadratic expression is an expression involving a square term. See, for example, x squared minus x minus 12 is a quadratic expression. X squared minus 4 because the highest power is 2. And negative 3x squared minus 4x minus 2. These are all examples of quadratic expressions. What are factors? Factors are numbers multiplied together to get another number. Okay, for example, I'll show you an example right now. What are the factors of 12? In other words, how can we get 12? 1 times 12, 2 times 6, and 3 times 4. So the factors of 12 are going to be 1, 2, 3, 4, 6, 12 are factors of 12. Example 2. What are the factors of 20? How can we get 20 is 1 times 20, 2 times 10, and 4 times 5. So the factors of 20 are going to be 1, 2, 4, 5, 10, 20. See, there you go. Now comes the greatest common factor. The greatest common factor of a set of numbers is the largest factor that all numbers share. So in other words, it's the biggest number they have in common. That's another way to say it. The biggest or highest number they have in common. Example, right? So we have the factors of 12 and 20. So what's the greatest common factor, or what's the greatest common number they have in common? You see, for example, they have in common the 1s, the 2s, and the 4s. But the highest factor is, or the greatest factor will be the 4. So my GCF, which is the greatest common factor, is going to be 4. That's my answer. So the GCF of 12 and 20 is 4. Okay, now how do we use a factor sheet? Okay, that's why this is crucial for factoring. Example, what are the factors of 12? Again, these are the same factors that we did earlier. And the 20, right? So the GCF was 4. How can we use this handout to actually find the GCF? So let's do it then. How does the factor sheet work? How can we get 12? So I'm going to go to 12 here, right? So I'm going to go to 12 and bring it down here. So the factors of 12 and then the factors of 20. Right? So bring it down here. So it's obvious that the biggest factor they have in common, right, is a 4. That's the GCF between 12 and 20. So this handout is crucial to use when you factor. Most instructors do not let you use nothing or no handouts when you factor. Neither do I. But this will help you actually when you're doing the homework or at home. Okay. This also works. This is just also like a calculator. Okay. The factor sheet, you can use it as a calculator. Okay, now, so let's start with the first step, right? The greatest common factor. What is the greatest common factor of 20 and 30? In other words, how can I get 20? 20 will be 1 times 20, 2 times 10, and 4 times 5. And 30 is going to be 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So what's the highest factor or the greatest factor they have in common? Well, the answer is going to be 10. If this was the factor sheet, right, all you do is look at the 20 and 30 and you get the biggest factor, which will be 10. That's how we use the factor sheet, right? I just show you in the previous slide. So now you have variables in math, right? So you have x squared and x cubed. So between x squared and x cubed, what's the highest factor? Here we have x squared is x times x, and x cubed is x times x times x. So how many x's do they have in common? It's going to be 2, right? But it's going to be x squared because x times x will give you x squared. So my GCF of the two variables is going to be x squared. Okay, now this is the observation. If both terms have the same variable, the variable with the smallest degree is a GCF. So for example, these two terms have the same variable, right, which is x. The x squared is a variable with the smallest degree, so the x squared will be my GCF. Now it's going to be factor out the GCF. Between 30x squared plus 20x cubed, right? I already did the work. So for example, between 30 and 20, right, the GCF was 10. And between x squared and x cubed, the GCF was x squared. So my GCF is 10x squared. So I'm going to factor it out. If I factor it out, what is left? Here you can do it two ways. You can actually multiply or divide. I like to multiply instead of division, but I'm going to do one with each one of these, okay? One of the factors. So for example, if you multiply, you're going to ask yourself, what number times 10 will give me 30? So the answer is 3. You factor out the x squared, right? And we need x squared, so do we need more x's? No, we don't. So for the first part, it's only 3. The plus, the sign comes down. Now let's do it the other way, right? With division. What's 20 divided by 10? The answer is 2. What's x cubed divided by x squared? Or here, right here we have x squared and we need x cubed. How many more x's do we need? is 1. So this is what's left. So yeah, if you factor out 10x squared, what's left is going to be 3 plus 2x. And that's crucial when we do it by grouping, okay? Let's do another example here. Example 3, you have x times 2x minus 5 plus 2 times 2x minus 5. If we notice, they both have in common the 2x minus 5, or the binomial here. This is called a binomial, the 2x minus 5. So you have that in common. So if you factor it out, right, and we factor it out, what's left? So if you factor 2x minus 5 from both sides, what's left will be x plus 2. So this is my solution, guys. Okay. So this is a complete form of factoring out, right? So if you have x times 2x minus 5, close parentheses, plus 2, 2x minus 5, right, is equal to 2x minus 5 times x plus 2. This example is crucial for factoring polynomials with 4 terms. Okay, now if 4 terms, right, we do it by grouping. Now, this is the way the book does it, guys, okay? The book and most instructors do it this way. I'm going to show you this way, then I'm going to show you a little modified version that I came up with. But for now, let's do it the way the instructors do it, and also how the book does it. They do it in groups. This is called group 1. This is group 2. So for group 1, right? For group 1, we have for the factors of 2 will be 1 times 2. For the factors of 8 will be 1, 2, 4, and 8. The ones in green is what they have in common. So the GCF between 2 and 8 is 2. Right? Now for the variables, you have x squared and you have x. Remember what I said earlier? The observation, if they both have the same variable, it'll be the variable with the least degree, which is 1. So that's why the x is what they have in common. So the GCF will be 2x. Okay? Now you're going to factor it out. You factor it out, what's left is going to be x plus 4. And you can always check your work, because 2x times x will give you 2x squared, and 2x times 4 will give you a positive 8x. Now let's do group 2 here on the right. Right, you bring the sign, so let's do group 2 now. So for group 2, the 3 is just 1 times 3. And the 12 is 1, 2, 3, 4, 6, and 12 are the factors. So the highest factors, the factors that they have in common are the 1s and the 3s. But the greatest common factor will be 3. If you notice, for the second part, right, the second term doesn't have an x, so they don't have no variables in common. So the GCF will just be 3. Okay. Now, if you factor out a 3 on the second group, what's left? X plus 4. Now you ask yourself, what do they have in common, right? Or what's the GCF? Is going to be x plus 4. What's left? 2x plus 3. So this is the factoring by grouping. Okay. Yes, that's your answer. Okay, now you see this is if it has 4 terms, right, on the factoring steps, and this handout I give to my students. If you're here in the presentation and you need this handout, you send me an email, and I can send it to you. Okay, but more than likely the instructors will not let you use it on the exams, but you can use it for the homework. And the more that you use it, the more you begin to perfect your factoring skills. So determine the number of terms, right? So now, right, so we're going to do the 4 terms first by grouping, and then we'll go in order after that. So this is the way I do it by grouping, guys. Okay, this is my method. Okay, you're going to find the GCF of the first 2 terms between 2x squared minus 5x, right? They don't have no number in common, right? No coefficient, but they have an x in, so it's going to be x. So I'm going to factor out the x. What's left? 2x minus 5, because x times 2x will give you 2x squared, and x times negative 5 will give me negative 5x. So whatever you did on the left, right, all you do is put on the right automatically. It's going to work, believe me. So the sign, you bring it down. Now here, something's got to go here, right in this spot here. A number's got to go there. So here is where you do, I like to use division, or you can use multiplication, right? I mean, I like to use multiplication here. So I'm going to ask myself, what number times 2x will give me 4x? So the answer is 2. And I can check my work. 2 times 2x will give me 4x, and 2 times negative 5 will give me negative 10. Now, what do the both terms have in common? Will be 2x minus 5. So you factor it out, what's left? X plus 2. So this is how I show the students how to factor. Now, again, I didn't come up with nothing, guys. I didn't come up with nothing different. I didn't invent nothing. I just modified it. I'm always looking for ways to make it easier for the student. So like I put here on the bottom, modified a little from the textbook. Here's what it says: the binomial that is left, right? The binomial that is left after factoring out will always be the same on the left side as on the right side. So, for example, this was what's left, right? So what's in the left, you automatically put on the right. When you can do it by grouping. So again, whatever I factored out, right, whatever was left, in this case was a 2x minus 5, I mean, automatically you put it on the right side, and it will work. Okay, now let's do two terms, perfect squares. So the formula for perfect squares means if you have x squared minus y squared, it will be x minus y and x plus y. If you have x squared plus y squared, if it's a plus, it's going to be prime. It means it cannot be factored. Okay. Okay, now two terms. Here we go. So, for example, here, guys, you have to know perfect squares. Perfect square means what two numbers multiplied by themselves will give you the number on the left. For example, x to the fourth is a perfect square, right? Because x squared times x squared will give you x to the fourth. X squared is also considered a perfect square because x times x will give you x squared. 1 is considered a perfect square because 1 times 1 will give you 1 squared. 4 is considered a perfect square because 2 times 2 will give you 2 squared, and so forth, right? So 9 is a perfect squared. 6 is a perfect square, 25, and so forth. It's good to know perhaps all the way to 12. But the more perfect squares that you know, the better you're going to be. Example. Example 6. So if I have x squared minus 1, right, we apply the rule. So it's going to be x minus 1 and x plus 1. X squared minus 4 is going to be x minus 2 and x plus 2. X squared minus 9 will give you x minus 3 and x plus 3. Because if you do the FOIL, right, if you multiply them both, you're going to get the expression of the binomial on the left. X squared minus 49 will be x minus 7 and x plus 7. X squared minus 81 will be x plus 9 or x minus 9. If you notice here, I changed the sign first, right? It doesn't matter the signs. You can have the same variable and number or coefficient, right? But different signs. It doesn't matter what's first, the minus or the plus. X squared minus 100 will be x minus 100. I mean x minus 10 and x plus 10. Now this one here is a little bit tricky, okay? But is 25x squared a perfect square? Yes, it is. It'll be 5x. Is 36y squared a perfect square? Yes, it'll be 6y. So this will be 5x minus 6y and 5x plus 6y. How about x squared plus 36, right? Remember, if it's a plus, it's going to be prime. Here's where a lot of students make the mistake because they assume there's going to be x minus 6 and x plus 6. But remember, it has to be a minus for you to be able to actually factor it out. But if it's not a minus in between, right, the difference, if it's a sum, it's prime. It cannot be factored. How about x to the fourth minus 16? This will be x squared minus 4 and x squared plus 4. If you notice, x squared minus 4 can also be factored out again. So there will be x minus 2 and x plus 2. And the x squared plus 4 stays as prime. It cannot be factored. So it'll be times x squared plus 4. Okay. So hopefully you got the concept on perfect squares, right? The difference of two perfect squares. Now let's do the difference of two perfect cubes, the difference in the sum of two perfect cubes. right? It's either the difference or the sum, and these are the formulas that we're going to apply. Okay, I call this 1 or 2, right? The difference or the sum. For the perfect cubes, you have to know perfect cubes. For example, x to the 6 is a perfect cube. Why? Because a perfect cube means what three numbers or what three variables multiplied by themselves will give you the perfect cube. For example, x to the 6 is a perfect cube because x squared times x squared times x squared will give you x to the 6. Also, x cubed, right, is considered also a perfect cube because x times x times x will give you x cubed. Same thing with 1. 1's a perfect cube, which is 1. 8's a perfect cube, which is 2. 27's a perfect cube, which is 3, and so forth. Right? So the more that you know, the better you're off. But at least know 1 through 25, which is the perfect cubes of 1 through 5. Okay? Okay, now, example number 7. We have x cubed plus 125. Right away, right? We should know which one is it, the sum or the difference. Is it 1 or 2? So it's going to be 2, right? It's going to be the sum. Because 125 is a perfect cube, which is 5. Right, so we have to rewrite it in this form. So x cubed plus 125 will be the same thing as x cubed plus 5 cubed. So here, guys, I'm going to let the x be my x, and I'm going to let my y be equal to 5. So here, everywhere you see an x, you're going to put an x. Everywhere you see a y, you're going to put a 5. So x goes there, right? X. The y is 5. X squared will just be x squared. What's x times y? What's x times 5 will be 5x. And y squared will be 5 squared, which is 25. So this is your solution. X plus 5 times x squared minus 5x plus 25. That's how you factor the perfect cubes. Most of the times in this course in Math 1324, you will hardly see something like this. Okay, this is more for the students going for math engineering, which will be the 1314 route. But if you're taking the next course, the 1325, which is the business calculus, you're going to see maybe 1 or 2 of these, but something with small numbers, something like this, like the example. So repeat, you will see this again in 1325. Now let's do 3 terms. Okay, I only did one example, guys, for the very same reason, because this is a long workshop, because it's 2 chapters and factoring. So now if we have 3 terms, right? I call it the easy factoring. Okay, here are the rules. Okay, my way of factoring, guys, is very different than the book and also some instructors, but it's got the same concepts. Again, I always focus on students coming back to school at a later age. Okay, and I believe this method that I modified from the book, it doesn't leave nobody left behind. Everybody can actually know how to factor by using this method. Okay, let's see if it fits your way of doing things. Of factoring. Okay, here we go. This is called the bx term. The second term is called the bx term, and this is called my constant term, right? So if the constant term, which you see, right, if this is positive, the same, it's going to be the same signs in the binomial, and we're going to add them. Okay, and we're going to add them to get the bx term. If the constant term c is negative, they're going to be different signs. So these will be different signs here. Okay, let me show you examples here. If you have x squared minus 10x plus 24, okay? If we notice, my constant term, right, is positive. So that means the signs are going to be the same. So like I tell my students, once you got the signs right, you're halfway there. So again, number 9, example number 9, we have 9 squared minus 7x minus 30. If you notice, the constant term, right, is negative, so the signs are going to be different. Number 10, x squared plus x minus 20. Again, the constant term is negative, so my signs are going to be different. And the last one, x squared plus 8x plus 15. The constant term, which is 15, is positive, so the signs are going to be the same. right? So once you got the signs right, like I said earlier, you're halfway there. Now I'm going to do each one of these examples on different slides here. Okay, so let me start with example number 8. Okay, this is only extra information. The sum of the factors must equal to the bx term, what I mentioned earlier. Okay, I'm going to explain all this on the next slide. Okay, this is example number 8, right? So same signs. So this sign comes down, so we know they're both going to be negative. Why? Because minus as a minus will give you a positive. So we're going to put it, right? So here is where we're going to learn how to factor. So we're going to get the factors of 24. And again, for the students that actually came back to school at a later age, right? And they don't know their timetables, which I've seen, right? You can use a factor sheet. The factor sheet is the one that I presented earlier in this PowerPoint. You can get it out, right? And you can get all the factors of 24. Okay, so the factors will be 1 times 24, 2 times 12, 3 times 8, and 4 times 6, right? And now that means that we're going to add the factors. So we're going to add them. The sum should give us a bx term, which is a negative 10. Okay, so here we go, right? So this will be 25, 14, because 2 plus 12 is 14, 11, and 10. So if we notice, my match will be 6 and 4. But remember, they're both negatives, so it's going to be negative 4 minus negative 6 minus 4 will give us a negative 10. So this is my match. This is my answer. Okay. Let's do the next example, which is example number 9, when you have different signs. So again, right, so this sign comes down. This sign comes down for a purpose, guys. Everything has a purpose. Okay, and again, I'm trying to reach all the students, not only the ones that that understand this concept. I'm trying to reach the students that don't know how to factor. So right, so this tells me they're going to be different signs. So this one you always bring it down, and right now I'll tell you why. So it's going to be negative and a positive. Why is negative and a positive? Because negative times a positive will give you a negative. Now we're going to get the factors of 30. How can I get 30? 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Right? This and also tells you what we do here. We're going to subtract them. The difference of the two factors must equal the bx term, which is negative 7. Now, what's 30 minus 1 is 29. 15 minus 2 is 13. 10 minus 3 is 7. And 6 minus 5 is 1. Where's the match? The 10 and 3. So since this is negative, right? So the 10 must be negative. So it'll be negative 3. Negative 10 plus 3 will give you negative 7. But check this out, guys. Check this out. This here on the right, I do that so you can see exactly what's taking place. If you bring the sign down, the biggest factor of the combo that will give you 7 will always go first. You see, so it'll be 10. Let me go back here. It'll be 10 and 3, right? Here's the observation. The sign of the bx term, right? This sign of the bx term determines the biggest factor. If you bring the sign down, then the biggest factor always goes first, right? Because the rule is this sign determines the biggest factor. So if you bring the sign down, the biggest factor always goes first. That's why it's going to be 10 and 3. Okay, now the next two examples, we're going to do it. This is how I show my students in class. Okay? So for example, right, the signs are going to be different. So the plus, we bring it down. It's going to be plus and minus. We get the factors of 20. 1 times 20, 2 times 10, and 4 times 5. And this sign, the constant term sign, also tells you what we do here. We're going to subtract them. 19, 8, and 1. Where's my match? The 1, right? So if you bring the sign down, the biggest factor always goes first. 5 and 4. That's how you factor that trinomial. Example number 11. Okay? We have x squared plus 8x plus 15. So again, the signs are going to be the same. So they're both going to be positive. We get the factors of 15. 1 times 15. 3 times 5. We're going to add the factors, right, because it's addition, so it's going to be 16 and 8. Where's my match? The 3 and the 5, so it'll be 5 and 3. That's how you factor. Now, we're almost done here, okay? I mean, for the factoring part. Now we're going to factor in the form of ax squared plus bx plus c. Like, it's called grouping. Okay, now, but grouping is going to be, right, it means that you're going to multiply the coefficient for the x squared term and the constant term, right? And then this here means 3 terms, 4 terms, 2 terms, and factor. This is what you follow, and this is also on the factoring steps. Example, right? So we're going to multiply the 3 times the 10, which is 30. How can I get 30? 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Right? We also add them. So it'll be 31, 17, 13, and 11. So the match is, right, we have to get 11 because that's 11, so my match is 5 and 6. So I mean, so remember here, right, we say we have 3 terms and then 4 terms and then 2 terms and factored. So my next step, I have to have 4 terms, right? We start with 3 terms, now we have to have 4 terms. So 11x, I'm going to put the 6x and the 5x, replace this by 11x. Now we're going to do it by grouping like we did at the beginning, right? We're going to group the first 2 terms. What they have in common? A 3x. What's left? X plus 2. What you put on the left, right, you also put on the right, x plus 2. We bring the sign down. What number times x will give me 5x? The answer is 5. We can check our work. 5 times x will give us 5x. 5 times 2 will give us positive 10. So I know I'm on the right track. Now, what they have in common? The x plus 2. What's left? 3x plus 5. Factored. That's the way you factor it when you have a coefficient on the x squared. Okay, let's try this one now. There'll be 18. How can I get 18? 1 times 18, 2 times 9, and 3 times 6. Right? We're going to subtract them. Factors to get the bx term, which is negative 3x, right? So the combo will be, there'll be 17, 7, and 3. So my combo will be 6 and 3. So since this is negative, the 6 is going to be negative. So it'll be negative 6x plus 3x will replace my negative 3x. So again, we start with 3 terms, right? Now we have to get 4 terms. And the negative 3x is replaced by the factors of negative 6x plus 3x. Now we group the first 2 terms. What does the 2x squared minus 6x have in common? It's going to be 2x. What's left? X minus 3. What's in the left, you also put on the right. X minus 3. The sign comes down. What number times x will give you 3x? The answer is 3. You can always check your work. 3 times x will give you 3x. 3 times negative 3 will give us negative 9. What they have in common? The x minus 3. What's left? The 2x plus 3. Factored. That's how you factor in this form. Now we're done with the factoring part. Now let's write exponential equations to logarithmic equations and vice versa. Okay, guys, definition of a logarithms to a base a. So you have y equals to log of base a x means a to the y equals x. This is logarithmic form. This is exponential form. Okay, now examples. Write each logarithmic equation into an exponential equation. If you have log base 9, 81 equals 2, right? So we know that you have to know what the x, the y, and the a is. Right, so the a is 9, the x is 81, and my y is 2. Now we go back to the exponential form. So it's going to be my a is 9, my y is 2, and my x is 81. So this is logarithmic form. This is how you convert it to exponential form. See, there's my y and there's my x. Now, this is example 15. Now we're going the other way. They're going to give it to you an exponential equation. You have to put it in logarithmic logarithmic form. So again, right, so my a is 5, my y is 3, and my x is 125. Right, so, and then, so it's going to be y equals, right, so my y is going to be 3. So I'll be 3 equals to log of base 5 of 125. There's the answer. Or you can go the other way, right? Or log of base 5 of 125 equals 3. So again, you have to know what the a, the x, and the y are for either logarithmic to exponential or exponential to logarithmic form. There's only 2 examples because these are very self-explanatory. So let me move on to the next thing. Okay, now in order to graph without a calculator, you must convert logarithmic equation to an exponential equation. These are examples of exponential functions. Okay, again, these are examples of exponential functions. Every exponent, the power is going to be a variable. Okay. Okay, now, how do we graph an exponential function? The exponent is a variable, it's a letter, frequently is going to be an x. So we have f of x equals a to the x. Okay, so a has to be more than 0, or it has to be positive. So we're going to be graphing exponential function. So this is how you graph an exponential function. It says find f of x when x equals to -2, -1, 0, 1, 2, and 3. So these are the values that we're going to use for x. Let's do ourselves a little table. So when x is -2, we're gonna evaluate f of -2 on the function, right? So we're gonna plug in -2 for the x. So the answer will be 1/4. So when x is -2, y is 1/4. Now let's find f of -1 when x is -1. So we're gonna get 1/2 to the first power, which will be 1/2. So when x is -1, my y is 1/2. Now let's evaluate when x equals to 0. So let's find f of 0, which means I'm going to go to my function and plug in 0 for every x. So 2 to the 0 power will give us 1. So when x is 0, my y is 1. Now let's evaluate at 1. Let's find f of 1. F of 1 means that I'm going to plug in 1 for every x. So 2 to the first power will give us 2. So when x is 1, y is 2. Again, let's repeat the process for x equals 2. So we evaluate at 2. So 2 to the second power will give us 4. So when x is 2, my y is 4. And lastly, let's evaluate f of 3. 2 to the third power will give me 8. So when x is 3, my y is 8. Now to graph it, guys, this is the way the graph looks like. If you notice, -2, right, is going to be 1/4. There's a point right there. At -1 is going to be 1/2. At 0 is going to be 1. At 1 is going to be 2. At 2 is going to be 4. And at 3 is going to be 8. There's your graph. Okay. Now let's graph logarithmic functions. So in order to graph without a calculator, you must convert the logarithmic equation to an exponential equation. Let me go back. What did I do? Let me go back here. Okay. So again, I have to go from y equals to log of base ax. It's gonna equal to a to the y equals x. So let's graph y equals to log of base 2x. So it's going to be 2 to the y power equals 2x. So now, right, we're going to do another table, but instead of plugging in the values for x, we're going to plug them in for y, because it's going to make it easier to evaluate when we plug in the values for y. So again, if we plug in the values for y, these are the values that we're going to get: 1/4, 1/2, 1, 2, 4, and 8. And again, if you plug in all these values there, guys, right, you can do it with a calculator. This is the value that we get on the x values. So here are the two graphs together. The graph in blue was the one that we graphed earlier on the previous slide. So for the logarithmic, it's going to be, these two are called inverse of each other. But anyway, how do we graph the log, right? When x is 1/4 means that x is 1/4 means that you're going to cut this first unit into 4 equal parts. So 1/4 will be out right here, so it's going to give us -2. When x is 1/2, right, it's going to give us -1. When x is 0, when y is 0, x is 1. When x is 2, y is 1. When x is 4, y is 2. And when x is 8, y is 3. So this is the way the graph is going to look like, the graph in red. Okay. So now now we're going to use the logarithmic rules to expand and condense logarithmic expressions. So for example, these are the properties that we should become familiar with. This is called the product rule, the quotient rule, and the power rule. If you have log of base a of x times y equals to log of base a of x plus log of base a y. For the quotient rule, you have log of base a of x divided by y. It will be log of base ax minus log of base ay. For the power rule, if you have log of base a of x, right, so the r power, the power, if you notice, goes to the front. So it's going to be r log of base ax. And similar fashion with the natural logs, with the ln's, right? The same properties hold. So with that said and done, let's expand on number 18. Let's expand them. Okay, so here the properties are going to be property number 1 because we're multiplying here, and also property number 3 because we have exponents, the product and the power properties. So we need to add 3 separate log terms, right? Because we have 3, so it's going to be three separate ones. Log of 5 plus, right, because we're multiplying, log of x to the 4th power plus log of y to the 3rd power. Now we apply the power property, which the exponents go to the front. The 4 goes to the front, so it'll be 4 log of x plus 3 log of y. And guys, if you notice, there's no base here. When you don't have a base, it's base 10. So base 10, it doesn't put it there. It doesn't have it there, but we know it's base 10. Same thing when you have the square root property, right? On the index, we don't put a 2 there. We know it's square root. Or same thing when you have a 1x. We don't put the 1 there. We know it's x. It's 1x. Same thing here. If there's no base, it means it's base 10. Okay, again, let's do another one here. So here, guys, right? So here we're going to have all 3 properties because we have a multiplication, the x times the y. We have an exponent, and we have division. So here, all 3 properties will be present. The product, the power, and the quotient properties. So to start off, right? Let's do the quotient rule first. So if it's quotient, right, it's going to be subtraction. Now let's apply the product property. I'm sorry about that. For the product property, these two, right, it's gonna be addition. So it's gonna be log of x plus log of y plus log of y squared. Now comes the power property, which the exponent must go to the front. So it'll be plus 2 log of y minus log of w. Okay, that's how you apply all these 3 properties at once. Okay, again, just do some more examples. I believe this time we're going to expand them. Put them in a single log. So here, right, if it's minus, it's going to be the quotient. Since we have a 2 in the front, a number in the front, that goes to the top. So it's going to be the quotient rule and the power rule, right? So execute the property. So right, so it's going to be the ln of x, right? The exponent goes to the front, I mean to the top, because if it's in the front, it goes to the top, minus the ln of x plus 3. Now we apply the quotient property. If it's minus, right, it's going to be division with a single log. Single log, right, so it's going to be division. So it's going to be the x plus 7 squared divided by x plus 3. So it's going to be the ln of x plus 7, the binomial squared, divided by x plus 3. Okay, now solving exponential equations. So you have to know about perfect squares. Okay, at least know all the way from 1 to 10 or 1 to 100, from 2 to 100. Perfect cubes. At least know all the way to 6, right? So for example, 2 cube is 8, 3 cube is 27, and all the way to 6 cube is 216. The more that you know, the better you'll be off. For the float roots, at least know all the way to 5. 2 to the fourth power is 16, 3 to the fourth power is 81, 4 to the fourth power is 256, and 5 to the fourth power will be 625. And also you need to know exponential expressions, right? A is called the base, M is called the exponent. The exponent rule, if you have a power raised to a power, you multiply the powers. And also solving simple one variable equations, something like that. You need to know all this in order to solve exponential equations without a calculator. Okay, so this is a rule we're going to use. Let A be a positive real number where A cannot be equal to 1. If A to the U equals A to the V, right? If you have the same base, then the exponents must equal to each other. That's what the rule is stating here. Example, we have 3 to the x equals 3 to the fifth power, right? So if these are the same base, then the exponents must equal to each other. So x equals to 5. Now, look at example 22. If you notice, the bases are not the same. So we have to make them the same. Okay? Not the same base. If you notice, we should know that 8 is equal to 2 cubed. Why do we want to put the 2 cubed? Because the right base is a 2. So 8 is equal to 2 cubed. So I'm going to replace 2 cubed for the 8. And then we bring down the x as the exponent. So then right then we're going to apply the power rule. If you have a power to a power, we multiply the powers. Or the exponent power rule. So it'll be 2 to the 3x equals to 2 to the fifth power. Now we have the same base. Now we can apply the rule. So the exponents must equal to each other. So 3x equals to 5. So we divide both sides by 3. So x equals to 5 over 3. And you can always check your work. Okay. If we plug in 5/3 for x, we will get 32. Okay, so 32 equals to 32. If you do it without the calculator, right? So I have to convert the 8 to the 5/3, right? By using the fractional exponent rule, right? Again, this is the radicand, the n is the index, and the m is the exponent. So all these two rules are the same one, but I like to use the last one instead. So 8 is the radicand, 3 is my index, and 5 is the exponent. So what's the cube root of 8? It's going to be 2. What's 2 to the fifth power? 32. So this is a rule that you use from exponent to a radical. Okay, and you'll be able to simplify without using a calculator. Okay, now example 23. Let's do one more. Not the same base, so let's make it the same base. So we always start 9 to the second power. Does it give me 27? No, it doesn't. That means that I have to lower or I have to find the common base between 9 and 27, which is going to be 3. 9 is equal to 3 squared, and 27 is equal to 3 cubed. So I'm going to replace 3 squared for 9 and 3 cubed for 27. 3 squared, bring down the x as the other exponent, and 3 cubed. So here we apply the exponent power rule. When you have a power to a power, we multiply the powers. So this becomes 3 to the 2x equals 3 cubed. Now we have the same base. So now we can apply the rule. So once we have the same base, you set the exponents equal to each other. So 2x equals to 3, so we divide both sides by 2. So the answer will be 3 over 2. Okay. And again, you can check your work. You plug in 3/2 for 9, right, and put in the calculator, it's going to give you 27. So I know this is true. This is a correct answer. Let's see here now. Now this is a little bit more challenging, right? But we still use the same process. So 4 squared does not give you 32. 16, so let's try 4 cubed. 4 cubed is 64, does not equal 32, which means that you have to downgrade both 4 and 32 with the same base, which is going to be 2. The common base is 2 because 2 squared is 4, and 2 to the 5th power will give you 32. So let's replace 2 squared for 4. Bring down the x minus 1. And let's replace the 32 with 2 to the 5th power. We apply the exponent power rule. So this will be 2 to the raised to the power of 2 parentheses x minus 1 equals to 2 to the 5th power. Now we have the same base, so we can apply the rule. So we set the exponents equal to each other. So then we're now going to distribute. So it'll give us 2x minus 2 equals 5. Right, we add 2 to both sides. So 2x equals to 7. We divide by 2. So x equals to 7 over 2. And again, we can check the work. Right, and we check it. We plug in the 7/2 for x. Right, so 7/2 minus 2 will give us 5 over 2. If you put that in the calculator, it should give you 32. So 32 equals 32, so we know it's correct. Okay. Now solving logarithmic equations. To solve logarithmic equations and exponential equations, you need to know previous properties such as, these are the properties that you need to know. Or the LN property. Okay, so let's begin with the example. You guys recall example 23, right? When we had this one, right, we had to find the same basis. We can do it another way. We can solve it by using the natural log or the LN. Right? We're going to take the LN on both sides. We need to bring down the exponent by taking the LN on both sides. What you do to the left, you do to the right. Now by the rule, the exponent goes to the front. Now we divide both sides by the ln of 9. And the answer is, the answer is going to be 3. 3/2. Okay, guys, so this is my solution. And again, at times some instructors want to see the actual work when you put them into the same base. And some other times, if they don't ask you right what to use, you can always use the ln for anything. This will actually work. Okay, but it's always good to know it both ways. This is very important. For example, the ln of a number is actually a value. It cannot separate it. For example, the ln of 9 goes together. That's why it's a number. Okay, and this is a misconception of many students that here they cancel the ln's, right, and they say it's 3. The answer is 3, which is wrong. It goes together. The ln of 27 is a number, and the ln of 9 is also another number. Okay, so be very careful with that. Now, here's another way to use the ln property. Right, so we're not the same base. We can do it. So we take the ln on both sides. So by rule, the exponent goes to the front. We divide both sides by the ln of 5. So there's my solution. Right, approximately, most of the times I want you to round off to 4 places. So the answer will be 1.2920. How do we check our answer? We plug the value that we just got for the x. So it's going to give you something real close to 8. You see 7.9996 is close enough because here, guys, we had to round off to 4 places. So it's a little bit short, but we know it's correct. Okay, now solving logarithm, okay, it says let u and v and a be positive real numbers with a cannot equal to 1. If log of base au equals to log of base ab, then u must equal to v. Okay, for example 26, we cannot apply the rule until we have the same logs on both sides. These are two different logs, so we have to use the properties that we learned earlier. To apply the rule, single log must be on both sides. We're going to use a quotient property on the right side. So we have to put this as a single log on the right side. So it's going to be the quotient rule, right? So the quotient rule means is if it's a fraction, it's going to be the quotient rule. So that means it's going to be log of x plus 3 divided by x minus 1. Now here, guys, right? So we can apply the rule because now we have both the same logs on both sides of the equal sign. So by applying the rule, it's going to be x equals to x plus 3 divided by x minus 1, right? Then here you can do it two ways. We can cross multiply, or we can multiply both sides by x minus 1. So if we cross multiply, it's going to be x times x minus 1 and x plus 3 times 1, because there's like a 1 on the bottom of the x. Now we distribute. So we have x squared minus x equals to x plus 3. Now we set the equation equal to 0 on the right side by subtracting x and subtracting 3 to both sides. That's going to give us x squared minus 2x minus 3 equals 0. Now we have to factor. So to factor this one, right, remember the signs are going to be different because that's negative. The first time we bring it down. And then we get the factor of 3, so it's going to be 3 and 1. Because 3 minus 1 is going to give us 2. That's where the bx term comes. But if we bring the sign down, like I said earlier, right, we put the biggest factor first. So it'll be the 3 and the 1. So we set both equal to 0. So x minus 3 equals 0, or x plus 1 equals 0. So we get x equals to 3 and x equals to negative 1. The logs cannot be negative. Okay, but let's check our work. Let's first plug in the negative 1, right, for every x. If you notice, if we put that in the calculator, it's going to give us error or not defined. That means the logs cannot be negative nor 0. They have to be more than 0. So that means the negative 1 is not a solution. Let's try the 3. If you plug in 3 for every x, right, we're going to get log of 3 equals to log of 3 plus 3 minus log of 3 minus 1. If you put that in the calculator, guys, right, you should get, right, so we know it's true. So this is a solution. But if you want, you can do it without a calculator. Right here, we're going to apply the quotient rule. So we're going to put it as a single log. Right, so it will be the log of 6 divided by 2, because if it's minus, we apply the quotient rule. 6 divided by 2 is 3, so we know that log of 3 equals to log of 3. That's another way to check your answer. Now, hey guys, I know that we're over, but like I said earlier, this is a very long 2 chapters and the factoring part. So I think I still have like another 10 minutes to go. Okay, and I apologize for that, but let me continue because this is very important for the students, because 1324 are placed and mini masters summer 1 and summer 2. Okay, now if we need to cancel the log of base 3, right? So we're going to raise, this is what the rule says on top here, right? If you have a to the power of log of base a, u, right? So that means that if the bases are the same, that's equivalent to 1. So we bring down the u. That's why the left side is equal to u. So let me show you how it works here with numbers. We have the base is 3, right? So we're going to put a big 3 on both sides, right? So the expression on either side becomes the exponent. So by applying the rule here on top, the 3 raised to the log of base 3, right, is equal to 1. So we just bring down the 6x minus 2. And then 3 squared is equal to 9. Right now, all we do is solve for x. So we're going to add 2 to both sides. So we have 6x equals to 11. We divide by 6. So x equals to 11 over 6. So that's my solution. And again, we can check our work. Right, I'm going to plug in 11 over 6 for the x's. If you notice, the 6 will cancel, so we're going to have 11 minus 2, which is going to be 9. If you put this in the calculator, log of base 3 of 9, right, by doing the change of base, it's going to give us 2. So 2 equals 2, so we know this is the correct answer. Okay. Now comes the last chapter, right? So I believe I'm going to be doing like a few examples from each section. Hopefully what can be done in about 10 minutes, at the most 15. So simple interest. The simple interest, this is a formula for simple interest. INT equals to PV times R times T. So the INT is a fee paid to use someone else's money. The PV is a present value. The R is the interest rate. And the key is that it's a number with a percent symbol. That means that's the interest rate. And the time is going to be in years. There's also another formula that we can get, right? We're going to derive it from using the left side. Right? We know that my interest earned is PV R times T. What do they have in common on the right side? The PV. So you factor out the PV. What's left? 1 plus RT. This is another formula that we can use. So the AV stands for future value, the sum of the principal and the interest earned, which means the future value. The PV stands for present value or principal, and the R stands for the interest rate, and the T stands for time in years. So you need to know, if months are given, then the time will be given months divided by 12, because the time has to be in years. And also, the interest rate must be in decimal, which means that you're going to move the decimal 2 places to the left and drop the symbol, or divide it by 100. 5 divided by 100 will give you 0.05. Okay, now, simple interest continue. Here's an example. Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest at 3.5% for 5 years. Find the total amount that Martha paid to her uncle, and how much interest did Martha pay? Okay, so we know this is going to be simple interest, right? Because it says there's simple interest. So which formula should we use? Does it matter? No. I'm going to use both formulas for this example. Okay, I'm going to do on one slide, I'm going to use the formula on the left, and on the next slide, I'm going to use the formula here on the right. Okay, so if I use this formula, right, because it says to find the amount that Martha paid, the future amount, and then how much interest did Martha pay. If you want to use the formula on the left here, the interest, right, then we have to use the FV equals to PV plus interest, because the interest, right, is finding the second part, which is how much interest did Martha pay. Then to find the full amount, it's going to be the interest that Martha paid plus the money she borrowed. That's why it's going to be FV equals to PV plus INT. Okay, now, so this is what I tell my students to put it like on the left side. You're going to put INT equals PV, R, and T. So they have to extract the information from the word problem. So for example, this is the money that she borrowed, so that's your present value, is at 12,000. The interest rate is 3.5%, which would be 0.035. The time is 5 years, so the time is 5. Put into the formula. Right? There's my PV, there's my R, my interest rate, and my time. So the answer should be 2,100. So that's the answer for the second part. That's how much interest she paid. Now, how much money did she pay, the total amount? So the future value will be the present value, the amount she borrowed, which was 12,000, plus the interest that she had to pay. So you add them up, and it's going to be $14,100 is the amount she paid back. How much was interest? The 2,100. Now, let's use the very same scenario, same problem, and use the other formula that we had there. Okay, again, same problem, but let's use this formula instead. This formula will give you the part for the first part here, find the total amount. And then for the interest that she paid, it's going to be the future value minus the present value. Okay, so let's do them. Right, so same as before. But now let's plug into this formula, which would be 12,000. 1 plus 0.035 times 5. Use your calculator. So this gives us the future value, the total amount paid, which is 14,100. Now to find the interest, right, is going to be the future value, which was the 14,100 minus the amount she borrowed, which was a 12,000. Okay, so it's going to give us the 2,100. So it doesn't matter what formula you use. What matters is that what's easier for you, for the student. Okay. Now let's do one more problem for simple interest. Look, this one here, example number 30. Mariana will need to pay a tuition bill of $7,500 for her daughter in 10 months. What dollar amount can she deposit today at 1.25 simple interest to have enough money to pay the tuition bill? And again, this problem is simple interest because here it's saying simple interest. So let's use this formula here. Okay, so what are we looking for here? What dollar amount can she deposit today? So we're looking for the present value. Okay, so she needs 7,500, right, in 10 months. So the interest rate will be 1.25, right, converted to a decimal will give us 0.0125. The time, right, is 10. So we cannot put 10 here because if we put 10, it's meaning this is in years. So it's going to be 10 divided by 12. That's in years. So let's plug everything in. So this is a formula that the book wants you to use, okay? But you can use the exact formula from the original, and use the inverse key, which I'm going to show you, okay? I'm going to show you both ways. Right, this you cannot put in the calculator all at once. Well, you can, but it's kind of hard to put everything in the calculator because it requires too many parentheses. So if you know how to use a calculator, you can use this formula here. But if you struggle using the calculator with the parentheses and all that stuff, I recommend not to use this one or to do it with steps. So the steps are we do the denominator first. Right, and then you clear the calculator, and then you do the 7,500 divided by what we got at the bottom. So that's your answer, 7,422.68. Now, this is the way I show my students. Another way without clearing the calculator. So you use the original formula, you put everything in. So here, guys, I'm going to put this in the calculator, how it is with parentheses. All right. This is what you should see on the calculator. Now I'm going to use the inverse key. So you press the inverse key, and then you enter the amount. When you press the inverse, this is what you should see on your calculator, and then you enter 7,500. Do not put multiply. Do not multiply. Just put 7,500, and you should see the answer. That's your answer, guys. See? By using the inverse key. And again, it's a steady flow in the calculator. You don't have to stop the calculator and clear it and then put the info. All you do is do it in one steady flow. And I believe from now on, that's what I'm going to show you by using the inverse key. Okay, now example 31. John received a $10,000 loan from his aunt to buy a car. His aunt charged him 2.5 interest. How long was the term of the loan if the interest accrued was 125? Okay, for this one, this was the interest earned, right? The interest accrued. So we're going to use this formula here because this is what the interest that accrued. So this formula is the one we're going to be using, on the left. What is given and what we're looking for. Okay, we're looking for how long, right? So we're looking for time. So the interest accrued was 125. Okay, put 125 here, guys, right? And then this is a present value, the 10,000. The interest rate is 2.5%, which is 0.025. And now all we do is put in the calculator. So we multiply the 10,000 times 0.025, we get 250. So 125 equals to 250. We divide both sides by 250. and we get 0.5. So 0.5 or half a year is the answer, half a year. Now let's start 5.2, compound interest. Okay, for compound interest, there's two formulas that they use, right? But this formula eventually is the same thing on the right. But the only difference is that I is equal to R divided by M, and the N is M times T. You see here it is. So it's always 7 things that you got to write down. The future value, the present value, the R, which is the interest rate per period, the M, which is the number of compounding periods per year, the T, the I is R divided by M, and the N is equal to M times T, which is the total number of compound periods. Now, what does the M stand for? Compound. These are key words for compound. So when you see the words yearly or annually, M is equal to 1. When you see the words bi-yearly or semi-annually, M is equal to 2. Quarterly, M is 4. Monthly, M is 12 because there's 12 months in a year. Weekly is 52 because there's 52 weeks in a year. Daily is going to be 360 or 365. At times the book says to use 360 for daily. But if it's not specified, then you use 365. And continuous, it's a total different formula. Okay, I believe I'm going to give you 2 examples of using this formula, and then 1 example of continuous. Okay, now compound interest can be used to invest a certain amount of money without depositing additional money. Okay, now example 32. Say you deposit $1,000 in an account at your bank that pays 6% interest compounded quarterly. How much money will be on your account after 5 years? And how much interest did you earn? Okay, so let's do that one. And again, there's a formula that we'll be using because it's easier to put in the calculator. Okay, so again, there's your seven things that we gotta extract the info from the word problem and put it on the variables here on the left. For example, what are we looking for? We're looking for how much money will be in the account after 5 years. So we're looking for the future value. So this is the present value will be 1,000. The interest rate will be 6%. Converted to a decimal, it's going to be 0.06. The number of compounds, right? The compounded is quarterly, so M is equal to 4. Right there, compounded quarterly. The time is 5 years. The I is going to be R divided by M, 0.06 divided by 4, which will give us 0.015. The N will be M times T. The M is 4 and the T is 5, so 4 times 5, which is 20. So plug into the formula. Right, so if you plug just the way it is, 1,000 times 1 plus 0.0125 to the 20th power, this is what they give us, right? So you run that out to your nearest penny. So for the nearest penny, you're going to run that out to 2 places. So you always look at the third decimal place. If this is 5 or more, you add 1 to the hundredths place. This is considered my 10th place, my 100th place. So the answer will be $1,346.86. How much interest did you earn? So we're going to subtract, right? So the future value, which was $1,346.86 minus what you invested, what you deposited, which was 1,000. So the answer will be 346.86. That's how much money you earned in interest. Okay, let's do another one here. This one here, guys, if you notice, it's the same problem, but it's compounded continuously. So that means we're going to use a different formula. This is a formula we're going to be using. Right, so we have the FV, the PV, the R, and the T. So let's find everything out. Again, we're looking for the future value. So my present value will be the 1,000. My interest rate will be the 6%. And the decimal will be 0.06. And my time will be 5 years. There's my formula, right? So plug everything in. Make sure that, be careful with a 0.065 times 5, right? To be safe, put parentheses, right, for the fraction, because at times when students don't put parentheses, right, what happens is that what it does, there's 1,000 times e to the 0.06, and then the 5, then you multiplies all that by 5. So if you want to eliminate mistakes, you put parentheses where the exponents are. So you, to be safe again, you put parentheses 0.06 times 5, close parentheses. You see, guys, it's almost the same answer, guys, but if it's compounded more per year, the value is more. You see, I believe it was 1346 on the previous slide. Here we got 1349 and 86 cents. That'll be your future value. How much interest? Again, we subtract the 1,000 from the $1,349.86. So we're going to come out with $349.86 as how much interest that you earn. Okay, now, number 34. I believe I have like one more. This is the last example, and then we'll do the annuities. Example number 34. I want to be earning an annual salary of $100,000 when I retire in 15 years. I have been offered a job that guarantees an annual salary increase of 4% per year, and the starting salary is negotiable. What salary should I request in order to meet my goal? Okay, so let's put down the formula. Right, remember the 7 things we're going to put down. So I want to be earning. So in other words, this is what I want to be earning. So that's your future value. So let me see, what salary should I request in order to meet my goal? So we're looking for the present value. So the 100,000 will be that the money we want in 15 years when I retire. My interest rate is going to be 4%. Compounded. Okay, so it's annually means 1. My time will be 15. My I is R divided by M, so it'll be 0.04 divided by 1, which is 0.04. And my N is M times T, 1 times 15. So it's 15. So now, right now, we plug everything into the calculator. If we do the 1 plus 0.04 to the 15th power, it's going to give us 1.809, right? 43506. Then we divide both sides by 1.800943506. So this is what we get, right? Okay, now I'm going to show you. This is $55,562.45. I'm going to show you how to do this in an easy flow without clearing the calculator. Okay? And from now on, guys, I'm going to show you this way. So you can input in the calculator, parentheses 1 plus 0.04, close parentheses to the 15th power. You should see this in the calculator, 1.809435506. Then we're going to get the inverse key. The inverse key is this key in the calculator, which I believe, let me get my calculator here. It's going to be on the first column where the ln symbol is. That's the, oh no, hold on. There's going to be 1, 2, 3. It's going to be where it says matrix. Okay, that key is their visual. It's going to be on the first column, the fourth row. That's a key that you're going to be using. So when you press that key, this is what you see in the calculator. And then you're going to enter the 100,000. And there's your solution. You see, guys, so if you do it this way, it's a steady flow of the calculator without leaving it. And this is what I'm showing my students in my class right now. The formula used in the book, this is a formula used, which I believe it can be a little bit challenging because a lot of students, they don't know how to use a calculator. And especially with putting the parentheses at the right place. So again, this is a formula used in the book and also on the My Math Lab if you ask for help. But this method is easier if you know how to use a calculator, and that's why I'm showing you how to put it into the calculator right now. Okay, now comes, this is 5.3. I believe I'm going to do 2 examples of each one, and it will be done. This is called the future value of an ordinary annuity. Again, these 2 are the formulas, right? If you notice again, the I is R divided by M. and the n is the m times t. Okay, now, how do we use these formulas for, in real life? The future value ordinary annuities can be used to accumulate funds for some time in the future. You must set regular deposits during a specific time. In other words, you're going to be depositing uh, um, the same amount of money like every quarter, every month, for a certain amount of time. Examples. How do we use this in real life? Here's an example. Let's say you can afford to save $1,000 every month and you want to set up an annuity to make interest on the account. You want to deposit $1,000 at the end of every month for 20 years. How much money will you have at the end of those 20 years? Another example can say, let's say you are planning on sending your just born child to college when he or she turns 18. Since college tuition is constantly at the rise, you want to make sure you have enough money in 18 years for your child to attend college. I explained these two scenarios today during my class. I tell my students, you guys are here to make money, right? I mean, that's why you're going to college. So more than likely, I believe like 75% of the students get financial aid or even more. If you're here to make money in college, right? More than likely, you're going to make too much money that your kid or your child is not going to qualify for financial aid. That's why you have to set up an account to start saving for her or him to go to college. So I'm going to do these two examples on the next two slides. Example number 35, right? So that's my formula. So let's extract the information. You can afford to save $1,000 every month and you want to set up an annuity to make interest on the account. So here's what we're looking for. How much money will you have in 20 years and how much will you earn in interest? So we're trying to find the future value. The payments are $1,000 a month. The interest rate is 3%, which would be 0.03. Compounded, right, every month means 12. The time is 20 years, 20. Now my I is R 0.03 divided by 12, which will give us 0.0025. My N is M times T, which is 12 times 20, which will give us 240. Now we do is plug it into the calculator, just the way it is, right? Well, here's how you're going to enter it in the calculator. Let me show you how we're going to enter it. We're going to start with the numerator. Let me show you again here, guys, okay? Here's where I show you guys. Here, with one steady flow. You're going to enter parentheses 1 plus 0.0025 to the power of 240 minus 1. So this in black is what you should see. Now you're going to hit the division key. Why? Because you're going to be dividing that value by 0.0025. So then you should see that on your screen. Then you're going to enter 0.0025, and this is what you should get, 328.3019981. Right now we're going to multiply by 1,000. So you're going to enter 1,000, and this is what you get, 328.301.9981. Right, so round it up to the nearest penny, we get $328,302. Now, how much money did you invest? Okay, so check this out. How many payments were there? 240, right? And there were 1,000 per month. So you multiply 240 times 1,000, it was 240,000. But you have 328. So the difference, when you subtract 240 minus a 320 minus a 328,302, is $88,302 you got in interest for putting 1,000 every month for 20 years. This is how much money you got extra, which is not bad. Okay. Okay, now let's do one more, and then we'll do the 5.4. This is the one that you're planning on sending your just born child to college when she turns 18. You want to have 250,000 in the account for tuition in 18 years. How much money must you deposit at the end of each quarter? Paying 5% compounded quarterly. So again, that's my formula. There's your 7 things. So now we're looking for the how much money must you deposit. We're looking for the payments. So the future value, right? You want 250,000 in 18 years. The interest rate will be 5%, 0.05. Compounded quarterly, so the M will be 4. The time is 18. The I will be R divided by M. The 0.05 divided by 4 will give us 0.0125. And the N will be M times T, 4 times 18, which will give us 72. Let's put into the formula. Now, okay, I'm going to show you with one steady flow of the calculator. So you're going to enter the numerator in the calculator, which will be parentheses 1 plus 0.0125 close parentheses to the power of 72, then minus 1. You should see, so we're going to get 1.445920268 on the screen. Then you're going to press the division key. Right? This way you should see answer, right? Division. So it's dividing that answer by 0.0125. So you enter that, and this is what you should see. 115.6736215. Then you press the inverse key. That's what you should see. And then you're going to enter the 250,000, and there's my answer. 2,161 and 25 cents. So those are your payments. Okay. So now let's see how much money came out of your pocket. So this is extra information. You made 72 payments of $2,161.25. So you can multiply those two, so we get 155,610. We subtract that from the total money you got, which is the 250,000. So in other words, you almost made 100,000 without of extra money, without doing nothing, just putting in, just making the payments for 18 years. So you got almost 100,000 of extra money, which is very, very good. So 94,000 came from earned interest. Now we need to do 2 more examples, guys, and we'll be done. This is 5.4. This is called the present value of an ordinary annuity. Now, most common use of present value ordinary annuities are for purchasing an expensive item such as a vehicle or a house at the present time and making equal payments, including interest, for a certain amount of time and years. So these 2 scenarios, examples, you want to purchase a car, what are the monthly payments and how much will you end up paying? Or you want to get an idea on the process of purchasing a house. To purchase a house, you must have a job, right? You must also have good credit. The higher your credit, the lower your interest rate you will get. Also, get pre-qualified for a maximum amount of the loan. So I'm going to give 2 examples of buying a car and also a house, and then we'll be done for today. This is example number 37. You buy a new car that costs $26,750. What are your monthly payments if the interest rate is 4.2% and the loan is for 5 years? And how much interest did you pay? Okay. Remember, guys, again, there's always 7 things. There they are, but there's a different formula. So we're looking for the monthly payments, right? So we're looking for payments. The present value that you borrowed, the money that you borrowed from the bank, was $26,750. The interest rate was 4.2%, which will be 0.042. The monthly payments, right? So the M is 12 because it's monthly payments. The time is 5 years. The I is R divided by M. So my R is 0.042 divided by 12, which will give us 0.0035. My N will be M times T, which will be 12 times 5 will give us 60. Okay, now let's put it to the formula. And again, since we're looking for payments, we're going to use the inverse key, okay? So we're going to put it in the calculator in a 1 steady flow. So we're going to enter the 1 minus parentheses 1 plus 0.0035 close parentheses to the negative 60 power. So we should see 0.189118531 on the screen. Then you're going to hit the division key. So you should see answer, right, which is this answer that we just got, divided by, then we're going to enter that 0.0035. After you do that, you should see on your screen 54.03385,802. Then we're going to press on the inverse key. You should see on the screen. So after you press the inverse key, you should enter the number on the left, which is 26,750. There are your monthly payments. So you're going to end up paying $495.06. How much money did you pay extra? Okay, so we're going to multiply the total payments, which is 60, times the amount paid every month. So it's going to give us $29,703.60. So you end up paying, that's how much you paid for the car instead of the $26,750 because the rest was interest. So how much interest did you pay? You paid $2,953.60, so almost $3,000 in interest. That's how much you end up paying for the car. Okay, now we're down to the very last problem, guys. Thank you for being patient. So this is number 38. This is a one where you want to buy a house. Okay, when you purchase a house, guys, say you want a house for $325,000. This is a 30-year fixed rate, which means that'll be the interest you're going to be paying for 30 years. When you buy a house, it's either 30 years or 15 years. But at times, there's a 20-year fixed rate, but most of the times it's 30 or a 15-year loan. What are the monthly payments and how much interest did you end up paying? Okay, so let's find out. There's my formula. There's my 7 things, right? So I'm looking for monthly payments, so we're looking for payments. The amount that you borrow from the bank, which is the present value, you borrow $325,000. The interest rate is 3.9%, which will be 0.039. The M is, again, with a house and a car, it's always monthly payment, so it's 12. The time is the 30-year loan. The I will be R divided by M, 0.039 divided by 12, which will give us 0.00325. And the N will be M times T, the 12 times 30, 360. Just put into the formula. And again, let's put it into the calculator in one steady flow. So let's start by entering the numerator. Right, so we're going to get 0.6890436,901. Then we're going to hit the division key. So we're going to see, this is what you should see on your screen, the answer, all right, divided by. You're going to enter 0.00325. This is what you get, 212.0134431. Now we're going to hit the inverse key. My students today, because I explained these problems today in class, and they love the inverse key. They're saying that it makes it real simple and easy with the inverse key. That's what they like the most. It's kind of funny, right? Anyway, we press the inverse key. Then we're going to hit the 325,000. We enter it. So these are your monthly payments. $1,532.92. Those are your monthly payments. So that's the answer for the first part. How much money did you end up paying? Let's find out. So there were 360 payments at $1,532.92. We multiply those. So you end up paying over $500,000, so $551,851.92. So how much did you pay in interest? We subtract the 325, right? So this is what you end up paying, right? So we subtract what you borrowed. So we end up paying over $250,000. So we end up paying $226,851.20 of interest. How can you avoid this interest fee? I mean, the interest, you're always going to pay interest, but it's always wise to pay a little bit more on the principal every month. That way, you don't pay that much of interest. Anyway, guys, I just want to thank you for being patient and staying this long. And like I said earlier, this was a long PowerPoint because it was two chapters and also the factoring part. And I want to thank you for staying this long. Thank you, Patricia.
Thank you, Mr. Azasi. I would like to thank everyone for coming today, and as well as Mr. Azasi for his time. And then I'd also like to invite you to next week's sessions. So on June 23rd, we'll be going over the new self-service banner, a platform to register and view your academic information for students. And then for Math 1314, we'll be going over exponential and logarithmic functions, properties of logarithms. And in Math 1324, simple and compound interest annuities and systems of equations. Thank you for coming today, and I hope you have a wonderful weekend.